Okay, so you can use these parameters here to basically adjust the sensitivity of this guy. Ideally, it should be able to capture only the object here. Now it is picking only the object. You can see that, which is amazing. That your contrast is so good and you're not picking a background and random things, which is amazing. So I can use this setup for imaging everything. But in case this doesn't work, which is a lot of cases, so then you use something called brute force method. That okay, you don't know where the object is, you just draw the thing and it will image and focus everything. Okay. In my samples, fortunately, I have very good contrast, so I can use this setup to capture images. Okay. So for now, for the sake of time, I will make a smaller scan. It will look for, if I click on this option you see here, it will scan and focus on sample only. It will only look for the object here and focus on that and image that. If I do this one, it will scan the whole area, but it will focus only on the sample. If I do this one, it will image everything. It won't apply any brain. Now sometimes if you are imaging at 20x, it's okay to have these random blank spaces. But if you are having a 40x image and you want to save time, instead of drawing just a box, you can actually draw any arbitrary shape. Okay. So for now I'll keep it like this. Now here, this is the edit focus map. So you can have different densities of focus maps. Why? Because the topography of this sample may not be flat terrain. It can be a little curved like this. So if I have multiple focal points, then depending upon the curvature of the object, I can adjust my focus up and down. It is coming from top, so it can be adjusted accordingly. The more number of focal points, the better you can reproduce this sample height. But if you have less, then you will be able to reproduce less. I know that sample is very flat, so I don't need to have too many. I just have a few points, so that's good enough. For usual case, middle is good enough. If not, then maybe this one is good enough. Okay, so for now I'll keep it like this and keep it within the sample like this, and at the edge, because this is trying to detect the edge of this object. Okay, so I'll say okay, and now I will just go ahead and do the next. Now there are multiple kinds of Z focusing methods. One is autofocus, that works pretty well if the object detection is very good and contrast is good. But sometimes your object is too thick, so you cannot focus using this autofocus. It will get confused. Okay, which plane to focus upon? Or if the contrast is not good, then it will not be able to use that. In that case, we click this, then it will allow us to go point by point and then use this to focus. Okay, or we can also press Control just like the other microscope. As soon as you do that, then you see this changes to Z, and then I can use the scroll to do a fine focus. This will be coarse focus, this will be fine focus. Okay. For now I'll keep it like this. Scanner. Now whatever steps I am doing, I can save that as a project right now, or as soon as the imaging is done and I verify that imaging is going proper, you see it is going to each point and it was able to focus. If it is able to focus, it becomes green. If it is not able to focus, it becomes gray. If you see too many gray points and no green points, it will keep going in loop again and again to try to focus. If it is still not able to, then you have to do manual focus all the time. Okay, so don't worry about this one. Now if I zoom in, you see here, this is the 2x, this is 20x, and you can see the folded area. These are not exactly in focus, which is fine. I don't care much about this image, but I have good enough area where I can do the analysis. Okay, so all of this setup is good. I like the settings. I will save the project. Okay, and I will call this as some today's whale training. Whatever I use, I just save it. So now all the protocols that I followed here can be now scaled up into other images. Okay, so I will just and you can, if you are happy with this image and you want to also scan this, you forgot about that, you can always add a scan. Okay, but for now we'll not worry about that. So now it is going to pick up the slide, put it back on the tray, and then again it will allow me to go back to the original window and pick up how many slides and how I want to load them. This time, instead of doing one slide manual, I will be going into the batch mode so that I can use the same setting on multiple slides. Okay, now I will go to expert batch, and then I can name the slides as required, slide number 2 and slide number 3. Okay, so these are named. I will go next. Now currently it is saving in somebody else's folder, random place. What I will do now is I will open the setting which I just created. It has all the information from what method I use, what magnification, where it was stored, everything. If I say OK, select these two objects and then apply the settings. If I want to apply on all, I will use this. If not, I will use this. And if I want to remove any of the selections, then I can just click this guy. Now if you see, it is currently now saving in the desired location with the desired settings. You can always go here and change the settings if required. And if you see, this is grayed out, meaning it's automated, so it doesn't make sense to focus each time, right? So accordingly it is set up. And now we can do overview scan. Now because it is going in batch mode, so there is an option for priority scan, meaning you can pause the batch scan and you can do manual load. So far in past 4 years, nobody has ever asked me to do that, but there is an option that if you are scanning 50 slides, suddenly you want to image one unique slide, then you can do that without closing everything. Okay? Alright. Now we'll calculate how long it takes for imaging one slide. So its time started now. It was 10:58. If it is taking maybe a minute, then if you have 50 slides, so 50 minutes of coffee break. Okay. Once that is done, it will allow me to review the settings, basically see whether the sample is, and draw the object or boxes around it, and change the focal points and everything. Whatever is required is done, and then it will go back to scan mode. And then it will scan, say suppose each slide is taking 3 minutes, so 50 multiplied by 3 is like about 2.5 hours. So that means it's a nice nap time, and your images will be acquired and it will be automatically saved in the location of choice, whatever storage location you specified. It will not keep the images open like this. Why? Because it knows that you are not sitting here. So if the images are not there after the scan, don't worry, it's stored in the location. Okay. While the scan is going on, let me show you the folder design so that you can know how to access the files. So if I go to here, and today's training is going on, so the file will be a tiny file like 1.7 megabyte, but the corresponding data will be stored in this folder, which is like 200 or 300 megabyte. Okay. So if you compare the names, both names are same, just the underscore is in forward and backward. If you change the name of this guy, you change the name of that guy. If you don't, you lose the data. And if you copy this also. So overall, that is how we use it. Now some people try to go ahead and try to open the file here, the ETS file. I have not been able to open it yet. So the best way to open that is use this VSI file. It will link to this folder and open the data accordingly. Okay. To open this, CellSense is good enough. It is available on this microscope computer. It's available on 3 of the workstations, and also 5 network licenses are there. So it's becomes very convenient for people to use it. Apart from that, ImageJ also is able to open it, Fiji with a special VSI plugin.